2 minutes past the time. Maybe someone will connect us. Oh. We got one viewer. Here, let's do something. What in my plan for today? A specific group of faults, not very popular in literature, but they occur quite often and may pose a serious danger. They are line interruptions. Line interruption on the first approach do not cause any significant overcurrent. So it's not so important. Okay, we can restore it sometimes. But there is one problem. When line is interrupted, one of the phase interrupted, we observe voltage asymmetric at a load. If our load is rotating machine, generator or motor, this asymmetric causes an overheating danger to this machine. For generators, negative sequence voltage over 10% of direct sequence is a reason for immediate shutdown. It's an emergency situation. For a synchronous machine, approximately 7 to 10% pose a real danger of overheating and burnout. So when we deal with some ordinary customer, maybe it's not so important, but connections of, let's say, a priority. What's a priority? Chemical industries, oil refineries, water processing plants, and so on. They all should be equipped with voltage asymmetric protection. Same for generators. Hydro generators are not so vulnerable, but high-speed turbines extremely vulnerable, vulnerable. So asymmetric protection should be It's mandatory. Should be installed. I would like to show a very common example. In reality, it happens often, but I don't know why it's not draws so good attention what it should be. So idea, I have a middle voltage connection, 10, I don't know, 11, 20, so on, 24 kilovolts network. Transformer, and here load customer with, let's say, active load and asynchronous machine. It's a very common setup. Question: what will happen here in case, let's say, one of the phase is interrupted? It's not something unusual. Switch falls. In era of my learning, very often switch oil switch had an insulation insert in the mechanics. This insert, break of such inserts means what one of the switch poles not actioning. All kind of faults with manual switch, misoperation or burn, and fuse burn. When burns only one fuse and remain unhandled. It's a quality of local management, but it happens happened not once and not twice. So idea, how can I let's say model regime when one of the phase is interrupted. I'm interested what happens here. On the one side, I need this modeling to select. Honestly, I'm not selecting this motor protection threshold from the scanner. When I submit my project, it should have overcurrent protection, it may have overheating protection. If it's an important thing, it should have voltage asymmetric protection. And I should prove what in case of phase interruption on primary side, this protection will trip. It's one of the part of my project. I need to perform a kind of sensitivity assessment. So this assessment should, for important customers, chemistry, refineries, water, in our environment, water processing plants, and mining industry, air exchange. Air exchange also, you may be asked for sensitivity assessment. Mining this water removal pump. All meaning life support. Air conditioned systems in hospital. Also, you need to perform a 100%, you will need to submit a protection sensitivity report for this hazardous, to obtain this hazardous operation permit. So you need model of this fault, and you need to compare.
Sir, in your project already published, right? In this project.
No, I'm not sure it should be published, but when you apply for permit in hazardous or life supporting operation, you need to add like a fire safety assessment and so on. You need to add report on blah 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 blah. Really, protection sensitivity assessment. What your project contain all necessary protections, and these protections are sensitive, so they will prevent catastrophic faults in case of. It's a base also for risk assessment for insurer. At the one moment. In our case, we need fire safety. It's in one case. We need a fire safety assessment. And another case, when we ask for connection to the state-owned distribution network, we need to submit a compliance assessment with the network code. We need to comply with the code, but code itself do not require this. This is required by permit on hazardous operation. Well, okay, I don't know. Maybe your customer will require, but for chemistry, medicine production, and so on, it's a mandatory. You'll see what means medicine production when you need to comply with GMP.
Is the phase control using?
Yeah, it's current operator, motor protection, and this, believe me, this thing will fail.
Fail. Ah.
Yeah, such protection will fail. It's too simple. You need to for hazardous. You need at last voltage shift relay.
Shift relay. Okay.
But voltage shift relay itself will you'll see will not work. My practice for real important case, you need a negative sequence.
Shift protection relay. Maybe
And it's out of step.
Maybe one page is start.
Voltage asymmetry relays.
Okay, voltage is not.
Voltage asymmetry relay. But for real important thing, you need something like this Siemens and negative sequence over current relay. But okay, first, how can we model such fault? Do we have a schematic?
Yeah, I think this one is right. The voltage protection is here.
Yes, and
the three phases is be connected in the relay.
Yeah, but what is relay number 50?
I don't know the relay.
Check it. It's a simple over current. Not enough. Simple over current is not enough. My super.
Is characteristic is a differential relay. Differential relay.
Again.
They are using two types. It's a old type related T, and this is a differential relay. They are using.
87 again. this one is for internal faults of the motor. This
It
port is for internal faults.
Internal fault, but
Yeah,
this port is
but we will, our fault is external. What I would like to draw a schematic. So let's assume we have a ref planted in phase A, B, C, and here will be our transformer. In such case, I will need equivalent resistance of the left side of my system. I mean, left is this, right is this will be N, this will be K. 1, K1. Sorry, where is my? I forgot one thing. Resistance. Equivalent resistance of the left side. This is M1. This is K1. Equivalent resistance of direct sequence on the right side. And maybe if you have a generation, you also may have equivalent EMF on the right side. Ground, neutral or common wire of the direct sequence. Maybe you can, nice arrow, you can have an EMF on the customer side. Next one, negative sequence. Equivalent on the left side and equivalent resistance of the negative sequence on the right side. And possible zero sequence. In case of distribution network, we will not see any zero sequence. In case you work in America, the distribution network, there are grounded network, distribution network, this will be needed. In our case, not, because we have an isolated network. Anyway, I can draw it. Zero sequence equivalent for the left side and zero sequence equivalent for the right side. This is N0 common wire for the zero sequence. And also what we need if there is a fault resistance, it should be added as 1/3. Connection, 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 they all go in parallel. All connects in parallel. And of course fault resistance. Yeah. Case network, general network for modeling such fault, it's mimic for the A phase. A phase interrupted, and this is network for A phase. Well, if you need other phase, just rotate results. is profitable to calculate or to perform modeling for A phase. One more, if we have isolated neutral, this will not need it. This part will be void. Okay. My network, I have resistors 5 ohm A, B, C. They mimic resistance of the distribution network. I'm assuming it's a city network with a cable. Transformer leads primary one delta connect, primary one is delta connected, secondary part is star connected. Here, active load as a set I have an ampere neutral. Also I have for A, B and C phase I have ampere matrix. Also for neutral, A phase current, B phase current, C phase current, neutral current. Also, this voltmeter shows A phase voltage and this shows B phase voltage. And I have a switch with asynchronous motor. And of course I can perform a disconnection on a primary side. It's a very tricky thing. Fault is on distribution network side, but you need to understand what happens at a load. I'm able to point also 60 ohm resistor here. Let's have some fun. Theory for such object, it's not easy to find. I don't know why. Okay, let's conduct our mimic schematic for this. You see, my network on the table models a common client connection, client which have active load, I don't know, it may be heating, it may be lighting something, and asynchronous, it's pumps or something like this. Systems map, let's say this will be my L1, connection point M1, connection point Q1. Resistance of my transformer. After that, it should be L of the load and also direct sequence resistance of my motor. Common. This is common wire or neutral of direct sequence. In physical, it's a ground. It's a ground wire. Here will be no. I also need a what I need? I need a network for negative sequence. Neutral of the negative sequence. In negative sequence, I will see my resistance, connection point M2, connection point K2, where the fault is, transformer resistance, and pair of it's a load resistance and here careful negative sequence impedance of my motor. It's important thing. They are very different. This one corresponds to the motor startup resistance. Because in negative sequence, magnetic field, what? Rotor goes directly and negative sequence goes in opposite. Double slide. Tuma, if here in direct sequence we have slide 5%, in negative what we will see? 200 minus 5. 185%. Double slide. Yeah. And if RF divided by 3, fault resistance. 1, 2, and 1, 2. Here is my mimic network. It's electrotechnics theory. Substituting my real network. Without symmetrical components, it would be pain of the paint because I'll need to account all metal inductance in transformer and all metal inductance in motor. With the help of symmetrical components, I can use splitted network and avoid modeling or metal inductance. Here, method of symmetrical components, this Fortescue transform, allows me to get network completely free of metal inductance. I don't know, it's 100 times easier to solve, 1,000 times easier to solve. But what I need to do now, I need to, I don't feel to solve it by hand. Machine will solve it for me. But to make it machine understandable, I need what? Node numbers, branch numbers, branch directions. Let's say this is node 1, this is node 2, this also 2, this also 1, this also 1, this also 2, okay? This will be node 3. This will be node 4. And common of negative sequence will be node 5. Now branches. Let's say 1. This may be 2. This may be 3. Okay. This is 3 and this is 4. This one, it will be number 5, number 6, number 7, this can be number 8, and fault resistance, let's say it's number 9. Here is my network. What I'm doing next, I'm conducting the incidence matrix. Maybe 3 tiny space for myself. I'm conducting the incidence matrix. So I have 4 nodes, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9 branches. Yes, it is. Who gonna feel it? Maybe artificial intelligence. One guy tried chat GPT on the DC network. Task. You know what the result? Appears you correctly solved the DC network problem. Really not. I found a mistake already.
That guy, international student or Latvian?
Yeah.
Latvian.
Text contains stupid mistake. In one place, the S, Zaroskite, number of branch, was used instead of Z, which is resistance matrix. ChatGPT ignored. There is no difference. For English speaker, it's not a huge difference. How do they know? Zar means branch. Zar in Latin is branch. Zaroskite, number of branches. Let's go fill the matrix. What I have? Branch 1 flows into first and no more connection. Branch 2, 2, 3. 1 minus 1. Number 3. Left third. Number 4, same. Number 5, from 5 to 1. From 0 from 5 to 1. Number 6 from 4 to 2. 1 minus 1. Number 7 from 4 to 5. Yeah. Number 8 again from 4 to 5. And this beauty goes from second to first. Let's check it. Active. One moment. I need. Oh, this one. Let's start new. One. Next one. I will need to solve a system of linear equation. So I will copy function of z that someone need to solve. At the end I will get a system of linear equation. I need to solve it somehow, so I'm putting the shaded techniques inside. And also I will need rotation operators. I will use them from previous. Let's give it some name. Okay, what I'm doing now, I need to write my network matrix. Who knows, maybe it's full of mistake. 3 zeros, 1 to 3 zeros, minus 1, again 3 0, minus 1. You believe it's correct?
Yes, correct.
Zero. Okay, let's go next one. 0, 0, 1. 3 zeros. 0, 0, 0. Minus 1. 2 zeros, 1. 0, 0, 1. what number 3, 0 minus 1. I need a slave to do this one. 0 minus 1 to 1. 1 5 zeros. 0 0 0 0 and 0. Okay. Now root 4. 2 4 5 zeros. 0 0 0 0. One more 0. 1 1 1. And last is 0. And 4 zeros. 0 0 0 0. 1 0 minus 1 minus 1 and 0. Questions about this? No. Very simple. Branch, node, if inflows minus 1, if outflows 1. Yeah. Let's go forward. This. And what's the next? Maybe I can reuse some. I can reuse parts of my code. Transformer remains the same. System EMF. Phase voltage of 200. Why someone? Okay, what I'm needed? I need to fill an EMF matrix. First branch, system EMF, and I need 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Looks okay. Fault resistance, I will use something different. I will use 60 ohms. Okay, first it will be huge. Then I will plant resistance. First I need to show a pure one. Okay, what can also I take? All about my transformer and load. I just reuse its code. I believe my transformer have short circuit experiment voltage 3.10% and losses 2.38%. So I can, from this data, I can get easily complex resistance longitude of my maybe anti-transformer. Also load resistance 0.88 amps consumed with 300 volts lamps at 130 volts. That's what I measured. Let let's go forward. Also my asynchronous machine. 2.2 kilowatt asynchronous machine, direct and negative sequence data from the handbook, except one moment, this 2.1, since I have no mechanical load, this machine is on idle, I assume what secondary resistance is very high, so as inductance I use data on no load regime on magnetizing circuit of this motor. It's for no load. Okay, let's go. Let's fill our resistance matrix. First two branch R1 and Z and transformer resistance are okay. Number 3, it's a load resistance. Yeah. It's a load. Next one is one direct sequence resistance of my motor. It's a 3 and 4. Number 5 R1. Number 6 transformer. Number 7 load resistance. Number 8 negative sequence resistance of my motor. Number 8. Yeah. Yeah, and here will be R4 divided by 3. Looks like I have filled resistance matrix. I will reuse piece of code. What I'm reusing? Number of branch, number of nodes, in very basic inversion of the resistance vector, transposition, transpose operation for the nodal incidence matrix. This will give me a nodal admittance matrix. I need to solve a nodal voltage equation system. I will do it by my Zeidel procedure. I will get voltages. I will get branch currents. I showed them. Now. And now one tricky moment. I need currents of my transformer. It's a indirect sequence, it's a second branch, and in negative sequence it's branch 6. But there is a small here everything will become big trick. I will put a huge exclamation mark here. Because there is one tricky moment. I'll show it. Okay, I can remain with currents. let's start first. I have put a very high value on fault resistance. First experiment will be poor. And to start, I will disconnect the motor by multiplying its resistance also. Huge numbers. First, I would like to show without motor. A bit simpler. Let's try to run it. Here I have my currents. Something. Yeah. What's wrong? Wrong it what? Machine will do only what asked for. See, I have my currents calculated. Let's try. It's in reality. Motor disconnected. Symmetrical load regime 090909 and phase disconnection switch. I have disconnected a phase on the primary side. 06, 064, 091 on the C phase. And here we see something different. Why? Why I put an exclamation mark? Where is my mistake? I also need to, let's put the voltages. Can we get lower voltages also? You see something wrong? Voltages, can we get voltages? Voltages. No, I can copy anything from here, but I can use this as template. Let's get direct sequence. It's node 3. And in negative sequence, it's node 4. I would like to get load voltages. I would like to get load voltages. This code should yield load voltages. Look, 124, 62, 61. Large voltage at the A phase. Looks like. Let's switch. This is A. This one is A, this one is B, and this one is C. Calculus. shows which voltage at the A phase, I C phase. Something definitely wrong. Where is my mistake? And A phase, see, drops to 60 volts, while B also 60.
Yes, almost similar.
I need a third voltmeter. I need a third voltmeter. What about voltmeters? Who would like to work with it? This guy will work for phase C. B, white 1. It's easy.
Mm-hmm.
120.
Oh,
It's
into two. Okay.
And it's a totally good idea. This one is only to 120, but we have 124 by calculus. Oh, I'll need 150. It's my mistake, sorry. I need to scale up. No, this one is the one. More voltmeters was a god of voltmeters. This one is for 150.
Now it's 120.
120. Bit high. Okay, so everything was nice except A phase. My calculus show A phase 124, and we see it in C phase.
It's
What
maybe the phase
difference?
change.
See? The A, B, C phase. C phase is higher and B lower. Not matching. Something wrong.
Maybe your connection may be.
No problem with connection. Key moment. This schematic corresponds to the primary side of transformer.
Okay.
When I calculate real values, I need to introduce rotation because I have a delta star connection. That's why I put
It's reversible.
It's one of the serious mistakes. That's why I put an exclamation marks here. This conversion, all this is as it at this moment I put a flat, and it's a mistake because this schematic corresponds to the primary side. I need also not only perform an inverse Fortescue transform. I need also to take into account sequence rotation by transformer. Transformer adds 30-degree shift. So I need this thing, rotation factor. Should I borrow you a knife? Connection is correct, don't worry. He's trying to understand the schematics. So, before... not. I can use... So, this one should be divided by... and this one multiplied by rotation factor. Same with voltages. And multiplied by rotation factor. If I'm not making a mistake. No, it's 1 second. No, that's not right. Second. BTV, do I getting a correct current? One second, let the whole current. No problem. Tiny problem. No. Non linearity. Like this, it's a problem of some. I will bring my motor back. Save and execute. I hit one problem because I use lamps instead of lamps. Disconnect 1.4, 1.6 and A phase should be. Yeah, what's something wrong here. This is a problem. A phase should have a large color, but I see in phase C. See, this one is A. I should get 1.4, 1.4 and 2.8 in A phase. And I see what? It's not a problem, but it's a phase C. And what with the voltages? Larger voltage in A phase. I have large voltage in phase C. Wait. This one. No, it's something wrong with the voltages. 2.4 is not possible. One mistake I have.
You got it?
Sorry. Sorry. Negative sequence voltage measured relative to the common. Sorry, it's my mistake. Yeah, there should be 95 in A and here. And we have low voltage. See what? It's A phase. They have 150, so it's real 95, and these two,
One, one, 15.
110, okay, 110, and this should be multiplied by 2.
For physics.
Right.
Right.
This should multiplied by 2. It's less than 100 for C phase. We have something like 100 in A phase. We have a lower voltage at the phase C and should have in A something flowing here. Let's look at all.
You want me to make it?
Let's unpaper. Okay, it's a phase A. Move this way. What's the angle? A. Do you see what does it say? It's not 0. And for phase B, again, yeah, but what's going on? Houston, we got problem. This is A. It goes here. It should have angle of. Okay, I can. Oh, it's motor power factor. Yeah, now it's 0. Okay, it was motor power factor. For phase B, there we are. 120 and lagging. It's okay. For phase C, 120 and lagging. Okay. So we saw now this one is phase A current on the primary side. It should be 30 degrees leading. It's only 10 degrees leading. What about this is B? This goes in. There is what's the negative? And it's 100 and lagging. originally it's 120 lagging and 30-degree rotation should be, yeah, 110 lagging. It's a B phase. And C phase current (130) and leading. The difference should be phase shift is strange. Not 100 on the primary side. There's not between that. It's not 100. Tiny problem. What we can do about it? What we can do about it? What we can do about it? This thing is powerful. Watch transformer. We can do this one. This one. Okay, let's maybe I'm wrong, but I have a feeling that something wrong with my transformer. Okay, what I'm seeing now, current of A phase. Current of the A phase. This is A phase on the secondary side. Yeah, I have now very nice shift or set it to 0. I need to set it 0 again. Please be 0. It's a current of the A phase. Now primary side. Current of the A phase flows. It flows to transformer. Yeah. Now it flows to transformer. What? Or current 0 degrees. Transformer primary side goes this way. This is fine. Rephrase on the primary. So. One arm. Right there. And rephrase on the secondary side. 120. From the 30 degrees, 130 volt on the secondary side, and put the full about series 120 here and some 110 here. Okay. Six. And much more that you can see. It's off. This is fun. Okay. I needed to compare voltages, of course. I know should be 30 degrees shift. Place one thing, transformer inductance is high enough. It is 300 volt, but star is a star. Now, what I'm doing along with, why I'm getting the wrong phase. I'm getting voltage, but they are wrong. Where is my mistake? I need to turn, this should be multiplied by, hey, what's happening? This should be divided by rotation factor. Or 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 one moment. To calculate correctly, I need a system EMF. I need a system to measure system EMF now, because I've disconnected this step-down transformer. System EMF now 244. Systems EMF now is 244. This let's see. I should get with motor or without. Let's check without. Without my motor. Voltages without motor. Disconnected, load connected. I get what I get. A phase. Should be 7. C drop to 100. This should be multiplied by 2. C phase element. C. It drops significantly. No, I haven't. And currents also wrong. Currents are wrong. Wrong. And this should be symmetrical. Wrong. What's my mistake? I made a mistake somewhere. propagation factor. Because I'm passing transformer. Here are my currents. Disconnected. So much current in C phase, not A. C not A. How can it be? Just for check. It's not for. A phase 0605, B phase 06803, 096, 1.18. Okay, let's assume it's nonlinearity of my balls. Motor running, 1 second. Let's calculate with the present of the my motor. Simple. Comment it out. Let's go. Current in presence of motor. Case of 4. 1.5. It should drop. What's going on? Direct sequence. 1, 6.4, number 7, not and yes, something giant, not playing on a role. I see no mistakes here. Yeah, it's so stupid. It's so stupid. one, phase C. 311. Not good. 113. No, wrong. Why I'm seeing the wrong phase? See the wrong phase. No, just a second. Any shit here? What's not? No. No. Why? I'm getting the wrong phase. My calculus show what current in A phase. In reality, I'm getting in phase C and voltages. One second, voltages. Without any shift. One to 9, 1 to 8, 1 to 7. And I have one, disconnect. C phase 120, B phase 110, and here something 100.
It's a good difference.
This plug my motor. Check the voltages. Should be C phase 75, but I see 75 in A phase. Currents should be C phase 1 amps. And small in a B. But I'm getting Yeah, getting a problem because my load is non-linear. I see 0 seconds current. Neutral current appeared. It shouldn't be. But I'm getting the wrong voltage in the wrong phase. It's wrong. Current switch motor. C-phase 3 amps. If calculate, if I calculate current with the pure motor, see 3 amps, but should be in A phase. I'm not getting in C. This is wrong. Not getting. What's going on? There should have been 3, 161, 161. 1.5, 179, 3.3, but wrong phase sequence. It's a wrong phase sequence. Definitely. Wrong phase sequence. I got the good current, but in the wrong phase. Calculus show large current in A phase, but really it's in C.
Reality?
Yeah, in reality in C. Where's my what's going on? Why I'm getting 0 in the primary side current? 0 end. Street transformer. It's a phase A. 0.
Why?
Okay. We'll make it 0. In such case, on the primary side,
Same.
with small difference, some 10 degrees. And it's wrong. check where voltages are. Now we get pair of bars. This is ground and a phase, how to connect. Here I have connected and sorry. A phase voltage is at 0. Okay. It's on secondary side. On a primary side, and this is ground, and this should be a phase voltage. And damn it. A phase voltage, 1 second. A phase voltage here, 30 degrees leading. 30 degrees leading is okay. This transformer is of group 11. This means what if I take A phase voltage on the start side as at 12 o'clock, A phase voltage at the delta side should look at the number 11, meaning 30 degrees forward, so 30 degrees leading. 30 degrees leading is okay, so A phase is an A phase. Now, B phase. For the B phase, I have lagging 90 degrees. Was lagging 120. Okay or not okay? 90 degrees lagging for B phase. Originally, B phase lags by 120, yeah? 30 degrees forward, 90. 90 lagging, good, and C phase. And C phase, uh, 150 leading. What would you say? 150 leading. Original C phase leads by 120. Yeah? Plus 30 degree due to delta star connection, 150. So voltages look okay. It's really ABC. Moment number next. So why there is difference because transformer has resistance. But now, super question. Why my calculus shows wrong phase? Where is mistake? One second for one moment. For interrupted phase, current on the primary side should be someone is online, 1 second. Hey, how you was the solution of that problem? Can we see it too? I'm working on this problem, 1 moment. I have a mistake somewhere. I'm trying to understand where. Say, wait 1 second. If I go upward, I will get primary currents. Let's check what I'm doing with primary currents. Where is some with the primary currents, and to get a primary currents, I will this one goes, this should be rotated by, and this should be divided by. I would like to make a simple check. Will I get a 0 in the phase A in current? No, I'm not getting. You see 0, but in B phase. I should get it in A phase. Why C? Why I got 0 in C phase, not in A? If I take my values at so, rotation factor is okay, it's 30 degrees. If there would be no rotation at all, if there would be no rotation at all, if there would be no rotation at all, I should get a 0 there would be more rotation and all. Branch 1 and 5 should produce 0. If I sum there, I will get a 0. Yeah? It's a 0. It's okay. At a fault play, current is 0. The same thing should be with the 2 and 6. And it's not 0. Where is my mistake? With the 2 and 6. 2 and 3 and 6 is from 2 to 5. One moment. From 2 to 4. From 2 to 4. Direction. 0. It was stupid. Now current at the fault place is 0. Okay. Next step. Next step, next step, next step, next step. This should be divided. This should be multiplied. It was without motor. I see 161 free. C phase, large current. Let's bring back our motor. Let's bring back our iron motor. Zero 27 1. One more mistake. 1.5. Okay. One more mistake somewhere. Where can it be? But it was stupid. It was really stupid. How can I compare results with motor plugged in with calculus without motor? It's stupid. It was a mistake in what days. Let's see what I'm getting. One moment. I will. One moment. Let's now see. Voltage applied. Load current flows. Motor runs. A phase disconnected. Now look what we see. Currents. A phase 161, 156. B phase 169, 179. C phase 322, 3.3. Voltages. A phase 170. Maybe. But it's B phase 54. And C phase. No, voltage is not. Voltages are not correct. We have full correct currents. B phase drops. And this is B phase. Yeah, this is B phase, this is C phase, and R, this one, yellow one is green. A, C, B. A, C, B. B drops. Okay. I'm a bit unhappy with voltage. Currents are correct. 8.3, yes, multi-transformer. Looks okay. It should be. What I'm doing here. Oh no! Parenthesis. Was like this. This means what? First,
Okay, it's closed.
it should be here.
Maybe we can.
It's autocomplete. Oh.
No.
Yes. And this is more possible. We need, where is my, let's check what we got. We need more possible. Let's see, motor running. Let's check. Three-phase voltage. This is C.
Okay.
124.
Yeah, it's okay.
116. B-phase. 101.
Almost similar. Okay. Maybe.
And A-phase. 104.
Maybe something different. But why this reading is giving it wrong?
A-phase shows 104. A-phase. You see, A-phase drops down. But here, currents are good, but voltages don't make me
Yes, the
happy.
is good.
Voltages don't make me happy. There should be some more. Currents are fine. Something stupid.
Exam, right? What we can write?
Yeah?
That's it.
Must be.
Need to person, right? Need to person. Nothing should be right.
Let's unplug our motor. And the difference is larger. Come on, come back.
Right?
to switch off motor temporarily.
Okay.
I want to see voltage is 717,274. No. So good, no, it's not correct. Because check for polarity. 44, 161, 139. Something wrong. Yeah, I have some 7 not following, so it's an A phase. B 1, it may be, and in B phase, this should be multiplied by 2. So,
Multiplied by 2, 30
yeah,
70.
70.
No,
We don't see now. Is that possible?
that's a miss.
I need to check one thing. In both load resistance number 3 from 3 to nowhere, from 3 to nowhere it's okay, and number 7 from 1, 3, 4 to node 5, it's okay. 2, 4, it's okay, and branch 2 to 3, it's okay. Here everything is correct. Here correct. Huge difference in voltages. Difference too big. It's too big.
161, 329, okay. But what about voltages? 120. There should be a higher voltage in C phase. In C phase. 133. I'm getting 124. I should have 115 in A phase. I'm getting 104 in A phase. Here I should have in B phase 116. I'm getting 101. And small zero sequence color. This is closed. Close but not perfect. I'm a bit unhappy. Currents are close. Voltage somewhere. Just for
Maybe you can check the input voltage.
input voltage I've checked. Correct.
230.
Yeah, bit another thing. Where's my error load? Error load. Oh, this is wrong. What's yeah. Let's check. If I disconnect this, connect this, and disconnect this. Currents 1414 to 7 to 9 to 8. Yeah, and what about voltages? 1 second. Voltages. Where is my down this
111, 120 on B, and 143 here. What difference? Something wrong here. To 79. Currents are correct.
But the voltage is
Voltage will be different. I got difference in voltages. Sometimes it's good to take a scope. A-phase drops. Drops in 7 minutes. It's I see drop in A and B.
yes.
I see drop in A and B. Drop in A and B. Вот here. Machine here. And yeah, drops in A and B. See? There is drop in C drops less, A and B with what 115, 116. We see difference. For position 1, I have damaged my transformer. Hypothesis 1, real transformer I make a okay, currents we got, but something bit wrong with voltages. Returning to where the tricky point is of all this. This schematic corresponds to the place of interruption. Switch to here. Where's the tricky point? Schematics corresponds to point of interruption. When we are looking for real currents at load side, we should consider transformer ratio, and here it is. Look what I'm doing with the currents. I'm introducing a phase shift by 30 degrees backward for the direct sequence and forward for negative sequence. Because transformer has 11th group. If it would be 5th group, if it would be 12th group, there will be no shift. If it would be 5th group, I should go forward for direct sequence and backward for negative. But this one is typical 11. So backward 30 degrees and forward, backward 30 degrees for direct sequence and forward 30 degrees for negative sequence. It's whether, that's why I put this exclamation marks. But I have a bit, something a bit wrong with my schematic. This difference in voltages, a bit strange. Don't know why. Reduction I already introduced here. At the moment, here is my reduction, so there should be no problem. Oh, and I forgot to test with 60 ohm. One moment, let's see what happens if I simulate not full disconnect, but disconnect through transient resistance. 60 ohm. One moment, I need share of line.
We are all sincerely writing. Sincerely you are writing. I mean,
Here is my 60 ohm. Oh, here is my 60 ohm. Voltage applied, motor runs. Yes. Motor runs, voltage applied. Disconnect. Now, A phase current calculated 125, 111, B phase 172, here 1.8, C phase calculated 279, I have 276, so currents are good. Voltages A phase 122 calculated, here I have 120, 115. B phase 126, I have 120, and C phase 135, I have 130 approximately. More precise, 128. And for B phase, 115 instead of 120. The currents are good, but voltages are a bit different. I see the difference. It's a bit strange, but it's what I got. Bit odd. Currents are good. In some degree, it's because of Lamb's nonlinearity. The resistance is dependent on voltage. And one thing I would like to tackle is a currents of motor. A phase current. No fault. A phase current is approximately 1.4 amps. In case of fault, it drops to 1 amps. B phase current. No fault, same 1.4. In this connection, drops to 1 amp. And C phase current. Rises to 2.4 amps. It's a serious difference in current. See? Phase of C current goes up. It's because negative sequence goes through without resistance. It will be I remove the 60 ohm transient resistance, and C phase current rises up to 3 amps, while B phase drops and A phase rises up to 2 amps with the transient resistance. A phase decreases. It's easy. Can we get motor currents? You have lecture after more?
Yes.
Ah. That means what I need to. Can I get motor currents? My motor sits in direct sequence in branch 4 and in negative sequence in branch 8. Branch 8. Okay. First test without RF. Without RF, motor current should be 2, 0, and 2.8. No RF, motor running, A phase. No, 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 no. Something wrong. Number 4. And number 8. 3, 4, 5, 6, 7. negative sequence of my model. It's okay. Alright, it's near 0. Cool. Yeah, man. 8. Disconnected. Oh, A phase. 1.8 instead of 4301 and 2.6 instead of 2.8. What I'm feeling, everything fine. It's fine, it's okay. I have calculated without transient resistance. A phase should be 2.0. I'm getting 2. B phase should be 0.81.
Okay, it's nearby.
It's
Oh.
below 1 second. Now it's full scale is 1 amp. Possible. And C phase should be 2.8 and 2.6, 2.7. And what if I point resistor? Point resistor. One moment. I need to recalculate with the resistor. I have a transient resistance. Now, A phase 155.
Okay.
1/4. B phase below 1 and C phase 245. 2.2, 2.3. It's possible. Currents are good. Bit hot. In such regime, motor burns within max within an hour. Water burns very quickly. You see, it's a huge asymmetry. But interesting thing. We got transient resistance. It's a faulty switch. See, voltages. If someone checks just voltage presence, it's okay, voltage will be. Voltage drops, but not so significant. And if you just remember your schematic with breaker, face to face. I said the schematic will fail, and it's why. See, the see voltage drops. But this drop is, see, your schematic will trip when voltage drops below 0.8 of nominal voltage. There is no 20% drop here in line voltage. But motor will burn. Because of asymmetry, rotor will overheat and it will cause fatal damage. That's why negative sequence relay or negative sequence trip function should be used. Voltage asymmetry will not work. In such case, see, without resistance, we have quite significant voltage asymmetry. But transient resistance lowers it. Asymmetry is not so big.
It's better if you get one.
You little motor. Okay, I assume it's enough for today. Or someone has some questions. Got 0 viewers. Stupid mistake was in 1 second. No, it was mistake. One moment there. In matrix, where my mistake is. Here was my mistake. It was stupid. It was stupid. Okay. I think it's